Today we're going to talk about writing the equations of hyperbolas. By the end of this video, you should be able to write the equation of a hyperbola in standard form. First, let's review. The equation of a horizontal hyperbola is x minus h squared over a squared minus y minus k squared over b squared equals 1. The equation of a vertical hyperbola is y minus k squared over a squared minus x minus h squared over b squared equals 1. It's important to remember that in a horizontal hyperbola, the x term is positive, the y term is negative, and in a vertical hyperbola, the y term is positive and the x term is negative. It's also important to remember that a squared is always the denominator of the positive fraction, and b squared is always the denominator of the negative fraction. So to find the equation of a hyperbola, we need the center, which is hk, and we need to know a, the distance from the center to the vertices, and b. For our first problem, we are given that the center of the hyperbola is 1, negative 2. We have one focus at 4, negative 2, and one vertex at 3, negative 2. Well, this means that we are going to have a horizontal hyperbola. We are told what our center is, so we need to make sure that we have A and B. Well, A is the distance to the vertex, so that means that A is 2. And the distance from the center to the focus is C, but we can use that to figure out B. So we know that C is 3. We also know that C is the square root of A squared plus B squared. So if we plug in our values of C and A, we can solve for B squared and get that B squared is 5. We could continue to solve for B, but we don't have to because in the formula we have B squared. So since it's a horizontal hyperbola, we know that the x term is going to be positive. So I'm going to write that first. And we have x minus h. And then we have y minus k. We know that the denominator of the positive fraction is always a squared, and the denominator of the negative fraction is always b squared. So that is our equation. Next, we are given that the foci are 3, 7, and 7, 7. And we know that one vertex is at 6, 7. Well, clearly this is also a horizontal hyperbola. And we know that the center will be halfway between the two foci. So our center is at 5, 7. We can tell that A, the distance from the center to the vertex, is 1, and that C, the distance from the center to the foci, is 2. Like we did on the previous problem, we need to plug A and C in and solve for B. So we have C equals the square root of A squared plus B squared. So we end up with B squared equals 3. Since it's a horizontal hyperbola, we're going to start with the x term, x minus h squared, and y minus k squared. Then we know that a squared is always the denominator of the positive fraction. So since a squared is 1, I'm not going to write that denominator. And then b squared is the denominator of the negative fraction. So that is our equation. Lastly, we are given that the vertices are 0, -6 and 0, +6. And we know that one asymptote is y equals 2x. Well, from the two vertices and from the asymptotes, we can tell that the center is going to be at 0, 0. We also know that this is going to be a vertical hyperbola. We know that a is the distance from the center to the vertex, which is 6. And then we need to use the equation of the asymptote to figure out what b is. So we can either count out the slope on the graph, go up to over 1, and know that that would be the corner of the rectangle that we use to figure out the asymptotes. And since that corner is 3 units away from the vertex, b should be 3. The other way we can figure this out is algebraically by saying we know that the slope is the change in y over the change in x, and we know that the slope of our asymptote is 2. We can see here that we're going to go up 6 and over some amount, and we can solve for b that way, and we would still end up with b equals 3. Since we know that this is a vertical hyperbola, I'm going to put the positive y term first. Since the center is at 0, 0, we just have y squared. A squared is always the denominator of the positive fraction, and b squared is always the denominator of the negative fraction. So that is our equation. And that's it for writing equations of hyperbolas.